Okay, trying to get some stuff done. This is a Heathkit SB-200 I'm going through. I'm just starting on. Um, this was actually bought or rescued from somebody's garage junk pile. I bought it on Facebook Marketplace. Local sale, cash and carry, and it was literally in a junk pile in their garage, and it was pretty rough. But I got it for that, pretty rough discount price. I think I paid $150 for it. I don't remember. I think it did have tubes, but I pulled them out. But $150 for it with tubes, but really rough condition. And actually it was covered in dust and other debris. And we actually gave it a little bath, a little steam bath already, even though it doesn't look like it. We haven't cleaned it and put some spray on it and wiped it down after that, so it still looks a little rough, but it looks a lot better than it did when I first got it. Meter scratched up, band switch is not working or froze. This the inside of it. The first thing I did is take out the high voltage caps there. They were can caps here, and took out the old can caps, and that's when I seen this kludge of equalizing resistors there. So of course that's gonna go. In the old days they used a lot of equalizing slash bleeder resistors, a lot of resistance to pull the peak voltage down to help regulate it, but nowadays capacitors are a lot smaller and cheaper, so modern thinking is you up the capacitance and you use less bleeder slash equalizing resistance. These were 70 watts and I think 30K across each cap, so it's a lot of power. And by the way, any bleed slash equalizing resistance, though some of it is necessary or else it's not going to bleed or equalize, right? So you need some, but to have heavy resistance, that's wasted power. That's just power going up in heat. And that's why you need the big resistors if you're going to have heavy resistance, which they did here. And them hot resistors, getting hot, they get out of tolerance, and it looks like somebody tried to do some kind of a repair or something with them there, or maybe they even tried to add some resistance, but that's a kludge, and that's the high voltage at that. So no, that's gonna go. We're gonna put in some higher value resistors for less heat, and we're gonna up the capacitance, because these originals were 450 volt, 125, 85 degrees, so they're not high temperature either. So we're gonna replace those with probably same voltage, but we'll probably up that to 175, 225. It's not critical, but we're gonna up that, up the capacitance, so we're gonna have more capacitance for better regulation, better filtering. And again, since I'm gonna have better capacitance filtering, I'm not going to need the equalizing resistors to bring it back down some, not as much. You need some, but you don't need a lot, and that's how modern amplifiers, build them now. We'll probably keep that board and just put in some can caps for those 6 resistors there. The diodes are up there. If they're good, we'll leave them alone. If one or more is bad, we'll probably replace all of them. It does look like it has the ham bands on the output. It's 10 through 80 meters. It's tapped at about 4 turns, if you can see it underneath there. Trying to zoom in on that tap right above my fingernail there. About 4 turns for 10 meters, and then the rest of the coils and these coils are used for the other ham bands. Originally I was going to leave that in there if the band switch is good, but the band switch is sealed. It doesn't look good in there. I can't get the camera in there for a good picture. Trying to put some light on it. So the band switch doesn't look good, and plus when I found out that the rear has input tuning, or supposed to, with the band switch going all the way back to the rear, and that's the back part of the band switch, but somebody already mono banded the input tuning, and that looks like the 10-meter band input tuner. That's the input tuner there. So somebody already mono banded the output to 10 meters, and since all the other tuners for the input are gone, which are these guys, right? And the band switches are kludge again. I will probably just finish that and do it right, and just get rid of all the ham band stuff and just finish mono banding it to 10 meters only. Recap it, get rid of the kludge of bleeder equalizing resistors there, higher resistance, and go through everything else. Like that plate choke is just hanging, that should be screwed down. Whatever else it needs, we'll go through. Anything obvious. Don't want to put crazy money into this. I hope the high voltage transformer works. If that don't work, we might even just abandon this as a project and use it for parts. But we'll get rid of, if the high voltage transformer works, we'll get rid of the other electrolytic capacitors, clean the relay, make sure all my solder joints is good, make sure all my screws and tie points and ground lugs and stuff like that are good and nice and tight. On the Palomar 300A and Phantom 500, those old amps, they are known to have loose grounds. The 50-year-old amp, that ground stud or studs like that, they get physically loose, so you don't get a good ground, you get intermittents and funky stuff going on, all because just basically tighten your screws. This power cord is messed up and frayed. We'll put a new power cord on it. Clean that up a lot. We haven't checked our fuses yet. Looks like the input SO239 is gone, so it's gonna need some work, but decent old amplifier. When they work, only 5,600 watts. 572Bs only have 160 watts plate dissipation. And I always say, you want to know peak output of an amp, you can go by twice the plate dissipation of the tube. So 2 tubes at 320 plate dissipation, basically 650 watt peak amp. And if you want to know bird watts, it's basically the plate dissipation. So 2 tubes at 160 again is 320, so about good 300 bird watts. 600 peak is all these little amplifiers do. You'll see it advertised as 1,000 or even 1,200 SSB. That's input watts. And if you know anything about input watts versus output watts, your efficiency comes in, and the amps run at about 50, maybe 60 if you're lucky, plate efficiency. So you basically lose half the watts that are going into the tube, don't make it out. And the tubes actually dissipate that, or as I used to term, they eat those watts. And that's where your other half of the watts go. So if you got a 1,200 watt amp, input, and it's putting out 600 watts, that other 600 watts are being eaten by the tubes, and that's why I always go by plate dissipation, right? And if you mistune an amp, so if you have a 1,200 watt input and you tune it down so it's only doing 200 watts output, then the amp is eating 1,000 watts, right? Because those watts aren't going out. And I showed that video of them 3500Zs turning red when I detuned it or mistuned it, because again, those tubes eat the watts when you don't tune it. One thing I do like about it is it's got the multifunction meter for grid, plate, relative output power, even SWR and high voltage. Probably be cooler if it had more meters, but again, I've said Heathkit is a economical built amplifier, including this one. 1 meter, undersized tank components, undersized band switch. Band switch is a big problem with these because they use a small size and it won't take abuse or misuse, or you know, if you turn that band switch while you keyed, you're gonna kill it, it's gonna arc, and other things, you know. Cheap fan. At least the power supply for this, you know, little amplifiers look decent. Still uses a voltage doubler though. But anyway, I guess that's enough to talk, and it'll be more to come on this one as I get the parts and start going through it. That's if the transformer's good. We'll probably do that next. Also, I always say check your fuses before you power this thing up, but we'll do that and see what we get. All right, that's it for this one. Bye.